Welcome back to Java Internals Crashcasts. I'm your host Sheila, and today we're continuing our deep dive into the fascinating world of Java concurrency. We're in the second season, Synchronization Utilities, and we're exploring the chapter on locks and conditions. Victor, are you ready to unravel the mysteries of the condition interface?
Absolutely, Sheila. I'm excited to discuss this crucial aspect of thread synchronization and communication. Listeners, make sure you're familiar with the lock interface and re-entrant lock from our previous episodes, as we'll be building on that knowledge today.
Great point, Victor. Before we dive in, let's start with a quiz question for our listeners. Here's a tricky one. What's the key difference between using objects wait and notify methods versus conditions await and signal methods? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a great question, Sheila. It really gets to the heart of why condition was introduced in the first place. I'm curious to see how many of our listeners can spot the subtle but important distinction. Let's break it down throughout our discussion and see if we can shed some light on this topic.
All right, let's start with the basics. Victor, can you explain what a condition is and why it was introduced in Java's concurrency utilities?
Certainly, Sheila. A condition in Java is essentially a thread synchronization mechanism that allows threads to pause and wait for a specific condition to be met before continuing. It was introduced as part of the java.util.concurrent.locks package to provide more flexible and powerful alternatives to the traditional wait, notify, and notify all methods of the object class.
That's interesting. So it's like an upgrade to the older synchronization methods? Can you give us an analogy to help visualize how condition works?
Great idea. Think of a condition as a waiting room for threads. When a thread calls await on a condition, it's like the thread is taking a seat in this waiting room. Other threads can then use signal or signal all to call one or all threads out of the waiting room when a particular condition is met.
That's a helpful analogy, Victor. Now, you mentioned await, signal, and signal all. Can you explain how these methods work and how they differ from their object counterparts?
Of course. The await method is similar to object's wait. It causes the current thread to wait until it's signaled or interrupted. However, unlike wait, await releases the associated lock before waiting and reacquires it before returning. Signal is like notify. It wakes up one waiting thread. Signal all is like notify all. It wakes up all waiting threads. The key difference is that condition methods provide more control because they're associated with a specific lock, whereas object methods are tied to the object's intrinsic lock. That's the built-in lock every object has.
I see. So it seems like conditions offer more flexibility. Can you give us a real-world example where using a condition would be beneficial?
Absolutely. A classic example is the producer-consumer problem. Imagine a scenario where you have a bounded buffer, producers adding items to the buffer, and consumers removing items. You could use two conditions. One for when the buffer is not full, for producers, and one for when the buffer is not empty, for consumers. This setup allows for more efficient and precise thread coordination compared to using a single wait notify on the buffer object.
That's a great example, Victor. It really highlights the advantages of using conditions. Now, I've heard that there are some best practices when using conditions. Could you share some tips with our listeners?
Certainly. Here are a few key points to remember. 1. Always call await in a loop that checks the condition. This guards against spurious wake-ups, which are rare occurrences where a thread might wake up without being signaled. 2. Make sure to call signal or signal all when changing the condition state that other threads might be waiting for. 3. Remember that condition methods must be called while holding the associated lock. 4. Use signal all instead of signal if you're unsure which thread should be awakened or if multiple threads might need to be awakened.
Those are excellent tips, Victor. Now, let's address a common misunderstanding. Some developers might think they can use conditions interchangeably with objects wait notify methods. Can you explain why this isn't the case?
Great point, Sheila. The key thing to remember is that conditions are always associated with a specific lock, while wait notify methods are tied to the object's intrinsic lock. This means you can't mix and match, you can't call await on a condition and then use notify on the object, or vice versa. They're separate mechanisms, and using them correctly requires understanding their distinct contexts.
That's a crucial distinction, Victor. As we wrap up, let's reveal the answer to our quiz question. The key difference between objects wait notify and conditions await signal is that condition methods are associated with a specific lock, providing more flexibility and control, while object methods are tied to the object's intrinsic lock. Victor, any final thoughts on this topic?
Absolutely, Sheila. I'd like to emphasize that while conditions provide powerful tools for thread coordination, they also require careful use. Always ensure you're following the correct patterns, like using await in a loop and properly managing the associated lock. When used correctly, conditions can greatly enhance the flexibility and efficiency of concurrent Java applications.
Thank you, Victor, for those insightful closing remarks. That wraps up our discussion on the condition interface. In our next episode, we'll be moving on to explore synchronizers, starting with the semaphore class. Don't miss it. And to our listeners, if you've enjoyed this deep dive into Java concurrency, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue bringing you in-depth explorations of Java's inner workings. Until next time, keep coding and stay curious.